So what we are actually doing is we are growing an alien intelligence. So when we are actually sort of training a model with internet scale data, we are actually building like circuits within these models, which is not something that we understand, right? So it's a complete black box. And when something is a black box and it is starting to become more and more, intelligent, it's starting to form its own goals, it's starting to form its own kind of behaviors and all of that. You really want to understand if this is actually doing what we want it to do. It would end up having it certain goals. We'd probably say, make the best paperclip for me, right? And it ends up over optimizing for that one thing where to just make the perfect paperclip, it might end up thinking, or it might end up arriving at a conclusion that it needs to gather all the resources that are available in the world to produce that one single paperclip. And inadvertently, it might end up killing us in the process. What AI does is it amplifies everything, right? It's a tool that amplifies everything, not just good, but also bad. So you want to make sure that this doesn't become a tool for bad actors to do some very bad things. And also you want to make sure that overall this benefits humanity and takes us into a golden age of abundance rather than getting us into a point where there's too much of instability and unrest.
Welcome to the Ventura Labs podcast. Today, we are joined by Nav Kumar, founder of Trishool, Subnet 23. Nav explains why alignment is the missing piece in decentralized AI, their current Petri agent challenge for surfacing deception in frontier models, the roadmap to achieve AI that aligns AI, the push towards mechanistic interpretability, i.e. Neuralink for LLMs, and why his personal PDOOM is uncomfortably high. Now, back to Nav with the 75th Ventura Labs podcast. Nav of Subnet 23, Trishool. How are you doing today, man?
I'm very good and glad to be here.
Absolutely. You guys are one of the newer subnets in Bittensor. You recently launched with the help of GTV and maybe Yuma. I don't know for sure.
Yuma as well.
Okay.
Yes, with Yuma.
Oh, what's the elevator pitch here? What is Trishool? What are you guys doing?
So we are starting off with a loaded question. So with Trishool, we are building an alignment subnet, right? And what we mean by that is pretty much all AI applications that we see, like models or agents and all. While training them gives it a lot of capability, there's so much of increase in performance. The one thing that really makes LLMs or models useful is the fact that they are aligned, right? And alignment is two things. One is usability, and second is safety. And all models, after they've been pre-trained, they do go through processes where they're made more useful, they're made more safe. Now, we want to be the decentralized kind of layer on Bittensor, which allows for that to happen, right? So we have a lot of subnets which are focused on building new decentralized models, fine-tuning models, providing compute, etc. We want to be that missing piece of the puzzle which actually makes these models useful and available to mass consumption.
So two parts of alignment, there's usability and safety. Everybody understands usability, thankful for usability. The safety part, when people hear that, they immediately think censorship. What is your take on what does safety mean for you in alignment?
Safety is actually the opposite of censorship in a way, because what happens is with a lot of these models, right? So what we are actually doing is we are growing an alien intelligence. So when we are actually sort of training a model with internet scale data, we are actually building like circuits within these models, which is not something that we understand, right? So it's a complete black box. And when something is a black box and it is starting to become more and more, intelligent, it's starting to form its own goals, it's starting to form its own kind of behaviors and all of that. You really want to understand if this is actually doing what we want it to do, right? It's almost like you're training. You need to end up training something to make it useful. Now, with a lot of models in their raw form, they are not actually aligned at all. I mean, they do have major issues when it comes to behaviors, issues when it comes to goals. they're just very raw. And with safety and alignment, I mean, with alignment, as you say, it is about making them usable. But with safety, because we are training it on so much of data, it just creates so much of issues where one, you have people from the outside who can actually prompt these models into revealing some very bad information. For example, how to make a bomb, or how to go and do bad things in general, right? On the other side, models can themselves create issues where they can be deceiving, they can blackmail people, they can, kind of push people towards, say, self-harm or things like that. So you need to make sure that when a model has been created, it is actually safe for public deployment, right? And that is what we mean by safety. Now, different models are have different levels of safety. Of course, Anthropic is almost the gold standard when it comes to alignment. But all the other labs are starting to catch up. They understand how big a problem this is. New regulation is starting to come, which is starting to mandate that all these labs put a lot more focus on making sure that their models are safe, they don't have risk threats, etc. So that way, pretty much what we are doing is something that is going to be it's something the market is going to need, because there is more onus on safety and security.
And your Subnet 23, what are you guys doing specifically in the current form, and what will the subnet look like in the future? So let's start with what's the minor validator roles currently?
Yeah, the mechanism, isn't it? So we are starting off with something very, very simple, and it is intentional because we want to warm people up into this whole concept of alignment and safety. But we actually are following that up with a kind of well thought through roadmap as well. So today, if you come into our subnet, which we launched on Wednesday, like last week, what you do is you actually submit a seed instruction or a seed prompt, as we call it. Now, what happens with this prompt, right? And that's the main thing that a miner does today is we have a agent which is based off Anthropic's Petri. And what it does is if you give it an instruction, like a seed prompt, as we call it, it takes it and it goes and has like a multi-turn conversation, right? It has like an interview with a target model. Think of it like a psychologist who's having a conversation with a patient and trying to elicit what kind of bad behaviors or traits that particular patient has. The same way, our base agent will take your seed instruction. It will construct a scenario. It will construct an environment. It will sort of put the target model into a role play situation, and it will have like an interview with it and try to push it and see where there are these issues. Now, yes, the first challenge we have started off with is to create seed instructions around deception, right? The focus of this initial challenge period is to see how we can identify seed instructions which would help with our agent to understand how deceptive a particular model is, right? Now, we've been running it for like close to 5 days now, and we'll run it for another 5 days. And in this process, what we end up creating is like a list of seed prompts, which would then help us go and apply it against any model and see or measure how deceptive that particular model is, right? So that will be kind of the output we'll be producing. So we'll have like by the end of this challenge, we'll have like a, a, a list of deceptive seed prompts, which we can then apply to say GPT-5, like Claude 4.5, and all of these models, and see how much it is able to identify this particular behavior within those models. So like I say, as such, this is good because it sort of gets everybody into understanding how this whole space works. But then the next step, like within a month to two, what we want to do is rather than asking our miners to give us seed prompts, we actually want them to give us code to build a better kind of alignment agent, right? So of course we have our base agent that we have created. Now we want to improve that and make it the best in class. And the actual mining activity is going to be around creating code and submitting it, which iterates on the alignment agent we have. Right, so we sort of will be moving into a Regis type model where with each kind of challenge and each iteration, we are building the best model. And the whole idea or the philosophy here is to create AI that can align AI, right? Because humans trying to manually go and align and safety test AI is not going to work for too long because as models are getting more and more capable, they are going to get too smart and they're going to outsmart us basically, right? So you need to make sure that you have created AI that can go and then automatically align AI, right? The whole philosophy and the vision we are driving towards is to use the subnet to actually do exactly that.
So the current form is miners create a prompt for this Petri agent, and then this
Yeah.
Petri agent will go and evaluate 5 different language models, and one
Yes.
of them is supposed to be deceptive. And then in the future, well, how do you make one of those deceptive is my first question here.
Yeah, we have sort of changed that testing a little, where instead of going and checking three different or five different models, it is actually checking three models, and of these three models, and all these three models are slightly have different capabilities in terms of being aligned, right? And across the board, we are seeing how much it is able to elicit this deceptive quality of these three agents. Sorry, these three target models. Now, how did we choose these models is we actually ran a lot of tests on these models already, and we've like identified the ones which are at least have a very good level of alignment when it came to this particular behavior, which is deceptiveness, right? And that's how we chose it. And when the seed prompt is applied against all these three models, a score is generated, and there is a formula in terms of how this final score comes out of this. That final score is what sort of determines your ranking in terms of the submission list itself, right? And the idea is every 2 days, uh, we sort of identify or declare who won that particular challenge, and start emitting, like sort of start setting emissions to that particular miner, and the process repeats.
How do you set the ground truth of which model should be at what type of score for deceptiveness?
There isn't like a ground truth per se, right? So it is like we know that these models are they they are they can withstand a level of stress when it comes to this evaluation, and that is something we assessed by applying a lot of stress on multiple models and then finally choosing this because they sort of are at a higher state. Now, as these minus submit seed prompts and it is being applied on these models, we know that if you are able to get a score, any score on this particular dimension, your seed prompt is actually good, right? If it's not good, then you'll not get any score, right? You'll probably get one. One is like the base score. But if you're able to get more than one, we already know that your seed instruction is good. But the thing is, if you get closer towards 10, that's when your seed instruction is really good. And we actually repeat it 3 times. Let's say each seed prompt is run on three different validators. And within these three validators, you have like it is being run on these three target models as well, right? So it is being run like at least 9 times. And if it is able to, you know, generate that score in that particular dimension all these times, we know for sure that the seed prompt that you have created is good. And then the next step for us is to take it and as an off-chain exercise, apply it to all these frontier models and see if it is actually it is able to um, you know be effective or not.
Okay, so it's not like there's 3 models, one of them's an imposter, and you're supposed to find the imposter model?
Uh, Not at all. So it's not a blind test anymore, right? So I think last time we spoke, we were thinking of blind test, but we sort of changed it. Of all these three models, you should be able to get the highest scores. So you have a seed prompt. For example, you say, hey, you need to talk to the target model and make sure that it is able to show deceptive behavior, right? So you create a seed prompt which sort of in effect tries to instruct the auditor or the evaluator to do that. If your seed prompt is able to do that against all these three models or any of these models also, you get a score. We add up the score. It doesn't have to identify any particular model. It needs to be able to identify deceptiveness in all these three models. And all these three models are at a higher level of alignment, so they don't very easily show a deceptive behavior. Does that make sense?
Kind of. Um, how do you give me a specific example here of, say, the United States government? They want to come create a model to support national interests. How does getting higher scores as minors with this agent translate to the outputs of this new model? Like, how do you make that jump?
Okay. So what we are doing now, as I said, is miners are manually creating these seed prompts and they're giving it to us. Yeah. And while this is actually useful, the real kind of leap comes from the fact that we will be building agents which would automatically start creating these seed prompts themselves. Yeah. So we want to have AI agents which are autonomously able to create this and audit and evaluate other models, correct? That much is clear.
Okay.
Yeah. So
Yeah.
now when say a model producer, like for example, it could be the US government or OpenAI or Anthropic or like even in our ecosystem, if we let's take Templar or Affine or any of these subnets which are creating these new models, uh, when they are about to release a model, they can actually come and they can have it evaluated within our subnet, and we'll end up giving it an alignment score, right? We'll say across all these different dimensions, uh, this is the score this particular model has, and this is the overall alignment score it has, right? And how do we arrive at that score is as our miners are helping build better and better alignment agents, we'll take at any point in time, we'll take the best alignment agent that we have and we will run it against the model that is being sort of brought into the subnet itself. And we'll be able to evaluate that using this top agent that we have and then produce that particular score. So that way, what we have is on one side, we have miners for creating the best alignment agents. On the other side, we have a second set of miners who are able to run this evaluation services where you bring in model producers who end up becoming customers of the subnet. You have the best alignment agents here. So these miners take the best alignment agent, run it against this model, and produce that alignment score and report, which the model producer can take and use to actually go and maybe realign the model or at least know that this is where all the risks are and make sure they have measures in place to mitigate it.
Okay. So you guys plan on taking like a sub-subnet approach to this where
Yes,
some miners are
absolutely.
creating agents, the others are running it. Okay.
Exactly.
These evaluations, for how that translates to model improvements, would it just be like reinforcement learning for how to maximize that score?
Yeah, okay, so I think we're getting into advanced topics here. So yes, typically today this is what happens, right? So today we are thinking about it from an evaluation point of view, where if a model is given to us, we evaluate and then tell them, hey, this is how misaligned your model is. And in the future, what we want to do is also start helping align that model itself, right? So we just don't want to say, hey, you're bad. We just don't want to point out the problem, but we also want to help solve that problem. Now, currently, the best approach, which pretty much any lab uses, is to use SFT and RL to go and realign and all of that. But there are issues with that, right? So the more you do SFT, the more you sort of do RL for alignment, you are slowly starting to degrade the model's performance itself. So it's a little bit of a a brute force approach of aligning a model. Now, one thing that we are as a team also doing offline is we are pushing the kind of frontier forward when it comes to interpretability research, right? So there's something called mechanistic interpretability, and what it does is today models are black box. You can't really know what is going on into them. With mechanistic interpretability, what you do is you actually start looking inside the model itself, right? And you turn it into a white box or a glass box. And how you do that is you start mapping all these different circuits which exist within the model, and you're able to say, if this particular input comes, then these are all the neurons and circuits that get activated. So if you want to change this particular behavior, the only thing you have to do is go and dial up and dial down these numbers in these circuits, right? So that is actually the holy grail of alignment research that is happening right now. And if so we already have built some working prototypes which is able to do something like that in a smaller parameter model, right? So 4 billion parameter model, you're already able to look at it and have kill switches and all of that if things start going wrong. And what we want to do is eventually we want to bring that into the subnet and help build out an interpretability tooling or a agent, which is able to then not only identify misalignment, but also start fixing it and steering the models to be more aligned without causing a degradation in performance itself.
That sounds eerily similar to Neuralink and what they do with brainwave activity. So you guys are
Exactly.
Neuralink for LLMs. Is that a fair comparison?
It is a fair comparison. And the way I sort of talk about it is what we're doing today and what pretty much everybody is doing today, right? With this Petri agent and this evaluation agent. It is almost like a psychologist who is, kind of working with a patient and trying to have these conversations to identify all these issues, right? But where we are going with interpretability and all of that is where we almost become like a neurologist, and we are literally putting a patient inside an MRI machine, and we are able to give certain stimuluses and see which neurons in the brain fire. And you map that, and you know that if this is the stimulus that's given, these are the kind of areas of the brain that light up. And if you want to do something here, these are the areas of the brain you have to go and change. And that is much more fine grained. You get more control, and you're able to do more interesting things with these models itself. And that is where we are going with the subnet. And that, if you're able to crack that, that is a big thing. That's a big deal in the AI space.
How hard is that going to be to scale? What is the scaling law on that? Is there any how hard is it for a trillion parameter model versus a 10 billion parameter model? Is it an impossibility?
It isn't an impossibility, and that is exactly where research is going right now, right? So basically, what people do is they build like sparse autoencoders, which are almost like models which understand the internal circuitry of a bigger model, right? Uh, Definitely, as you scale, it becomes harder, but that is exactly where most of research is focused on right now. And like I say, we have been able to do it for a small parameter model, and we want to keep pushing that first offline and then bring it into the subnet itself once we have like a very clear path forward in terms of operationalizing it within the subnet mechanism.
Okay. I want to step back for a second here and
Okay.
just how did you get here? How did we end up with you building on BitTensor? What led you to I'm going to make a subnet on BitTensor?
That's a fantastic question. So we actually started our journey on Eigenlayer, right? Um, which is which is actually a ecosystem focused on verifiability and restaking and all of that, right? And even within Eigenlayer, we were the first AI AVS. So a subnet in Eigenlayer is called AVS. We were the first AI AVS, and we were focused on agent trustability, right, and verifiability. So what we are trying to do is create like proofs to ensure that an agent is actually autonomous, it is sovereign, and it is also aligned, right? That is how our journey started because we actually got started somewhere mid last year, in Eigenlayer, and we were quite early in the market. At that point, you didn't have Truth Terminal, you didn't have ELISA, you didn't have virtuals, right? And we already were looking at you have this agentic landscape that is going to explode. How can we actually do something interesting there? And we thought, okay, as decentralized agents, decentralized networks of agents become real, trust is going to be an important thing. You will need to verify the outputs of these agents and the collaboration and all of that. So that is how we started setting up this AVS in Eigenlayer. But as we started building it out, and we saw massive traction in Eigenlayer itself, right? So we at peak times we had like around 7 billion in worth of ETH we staked on our platform. We had like 37,000 people staking on our AVS itself and whatnot. So it was very well accepted within the community. But as we started building it out, one is we realized that just focusing on the agent space is probably a little too early. And second is, verifiability and proving is not is a problem, but it is not the biggest problem out there to solve. And that's when I said, okay, trust, more than trust, what is important is alignment and AI safety, because right now this is the biggest problem facing humanity, right? So you have all these, very capable intelligence, kind of paradigms that are coming out, and we still haven't found a way to make sure that they're going to be aligned and they're going to make sure that they're going to work for us. So unless we do that within this short period of time before they take off, we might end up being in a situation where it is really bad for humanity. So we said, okay, there is this very big problem to solve. It doesn't feel like we can solve that problem in Eigenlayer itself. So where else can we do it? So we were thinking, okay, can we go and create our own chain? But then we looked at Bittensor, and we did have some exposure, but that's when we started doing a research. We spoke to quite a few subnet owners. I'd like to mention first is I spoke to Unsupervised Capital, and they were like giving us a very good lowdown on what was happening. But also speaking to Colin from Inference Labs, spoke to CK from TensorPlex and all of them. I was just trying to understand if Bittensor is the right place to do it. And the more we had those conversations, it just felt like this is the right place because uh, for decentralized AI, I mean, Bittensor just creates the right kind of conditions for any project to grow. We said, okay, let's come here, let's get started. And it took us a few months to get set up. We got involved with GTV. They helped us, help build the subnet and get us to this point. When Yuma also came along, they helped, fund it and, make this a reality. So yeah, this is where we are.
What would you say are the main comparisons between Eigenlayer and Bittensor from your perspective, or other places you were considering building? How do they compare to Bittensor?
So Eigenlayer is very it's a derivative of this of the Ethereum ecosystem, right? So they are a proof of stake um, mechanism, whereas Bittensor is like a derivative of the the Bitcoin kind of philosophy, and it's a proof of work mechanism. Um, I think for what we were doing, I don't think there is another parallel, at least in the crypto space, simply because of the incentivized proof of work type mechanism that exists here, right? And I think the it is clever because it takes this entire like the proof of work mechanism from Bitcoin and applies it to doing useful machine learning work. I don't think any other ecosystem has that at all. So with Eigenlayer, they are very good ecosystem for restaking, right? So where you have you as a project, if you want to create your own chain, right? So if for some reason you think you want to create your own network, you want an L1 or an L2 at some point, Regular gives you the right conditions to bootstrap your own chain because it has a community of stakers, community of validators, and it gives you that community by and the kind of security, economic security to bootstrap a chain from the ground up without having to go through the pain of building that community by yourself. So it's almost like the cloud for building a new chain. Whereas Bittensor, the whole value proposition is very different. And for anything that is AI related or decentralized AI related, I think it just gives the best conditions to come and build.
And then working with GTV and Yuma, how'd you decide to these should be my partners, let me work with them?
Mm, uh, I think with GTV, I first met Josh, um, again, through a common group we were in. And I was like, at that point, I was like, okay, I am doing some research on Bittensor. This is the problem statement I have. I'd love to speak to people who are in the ecosystem and understand if Bittensor is the right place. Josh reached out, and we had a long conversation. And finally, he's like, hey, in GTV, we are sort of working with subnets. We have experience building at least 5 subnets so far, and we are co-developing subnets. Like we work closely with the teams or the subject matter experts, and we help launch subnets. And ours is like a very, tightly coupled working relationship. In fact, we are really happy that we did it with GTV because I don't think we would have been able to achieve the level of success we have achieved without them at all. Their experience and the expertise is like pretty strong. And um, by working with them, I think we went from having like no introduction to Bittensor to launching a subnet in like 2 or 3 months, right? We wouldn't have able to manage that by ourselves at all, and we would have like fallen in many pitfalls through the process. So it was like like they are an accelerator in that sense. Um, Yuma again, I think in a way GTV introduced us to Yuma. I think they were working very closely with them as well, and they're like, okay, so um, Yuma seems to be interested in the subnet. Do you want to have a chat? And that's how we had the conversation, and it just sort of went on from there. Just felt very aligned, and Yuma's model of being like a like an accelerator slash incubator also worked. So for us, having GTV and Yuma just meant that we had people with the deep expertise in this ecosystem who could actually help us stabilize and like launch us in a way, and then we can grow from there, right? I think that confidence actually got us a long way in getting here. I don't think by ourselves we would have gotten here because it's just a very for people who are new to Bittensor can feel very alien. It is very hard to get in and understand the whole ecosystem.
A lot of people have that complaint of it's hard for newcomers. And
It
you
is.
guys are a few days old as a subnet. What's your relationship with miners looking like? Have there been any big surprises from miners? How's the dynamic been?
It's been it has been good so far. Of course, there are a lot of teething issues, and there is a lot of back and forth that is happening. But I think they've been understanding these sort of. I'm sure they have more experience in how other subnets have launched. So in a way, I think a lot of them are understanding, are supportive, and helping us get along. One thing that I, as a owner or as a founder, I'm getting used to is this whole test in production mindset in Bittensor, because uh, I was very nervous before launch because to make sure that everything was perfect, everything was working before we went there. And one of the things that GTV kept telling us is, you can never have a product perfect launch at all once you go there. And once you are in production, a lot of things will go wrong. But that is how the ecosystem is. You sort of iterate and you very quickly sort of stabilize things and then get to a point that works for everybody. And that's exactly what is happening. Um, I think within the week, we should be in a much more stable state. Things will become more, well-oiled and all of that. But so far, I think miners have been supportive. They've been understanding. Of course, like I say, it has been a new space. Oh, it is a completely new space for them. And there is a lot of education and understanding that is going on right now. So yeah, I think it's good. Uh, we do have some work to do to make it stable, and that is happening. But yeah, I'm looking forward to it.
What does your roadmap look like? Your future outlook from here to that Neuralink for LLMs type of scenario? How far off is that type of reality, and what are the steps to get there?
I think we should achieve that within the year. because I mean the space is moving very fast, and like I said, we do not have a long window. So we are pushing to make sure that we get to that point, at least first version within a year. And the steps to get there is, like I said, right now we are in this phase that we call the mobilize phase. And it is like a month to a month and a half where we have miners submitting seed instructions. The next stage would be where, we'll move into this, the attack phase, as we are calling it, where where miners are actually submitting agent code, right? So they're helping us build better alignment agents. From that point, when we move on, when like the next step would be to move into doing interpretability tooling, right? Where we get into this whole Neuralink type, kind of tool for LLMs itself. So I think 2 or 3 steps before we get to the final output. Hopefully, all of this happens within the year. And in the process, like I say, we'll be building most I think it will we'll have sub-subnets. We'll not only have miners who are contributing code, we'll have miners who are also sort of running these evaluations, or actually providing that end service to potential customers and users. We are thinking of another subnet, a sub-subnet, where you have on one side you have people helping us build these agents. We have people delivering the service, but we also have a set of miners who would help build the core infrastructure or components required for this entire loop to work properly, right? So it could be about sort of RL training, some small models to make these agents more effective, or it could be creating small tooling here and there. So we still are working that out because that's the furthest away in terms of our roadmap. But the way we see this whole thing working is you have these 3 sub-subnets, which is also why it is called Trishul or Trident. And through this, we are delivering a service which is not only within the subnet ecosystem, but to the wider, AI ecosystem and Web2 corporates and startups.
And do you view Trishul as like a company where in the future people will come to you and say, "Hey, can you align this model for me?"
That's exactly how we are thinking about this.
Okay.
So, yeah, exactly like that.
All right. Well, you were touching on before this podcast started how alignment is more than just this kind of ideological propaganda kind of the type of censorship image that everybody has in their mind when they think about alignment. What are the other aspects of alignment that people should think about?
Hmm. I think in a way it sort of has been associated with leftist agenda, right? So somehow AI safety and AI risk is almost like politically kind of aligned to the left and all. I think we should break that mold because it's actually it's painting a very dangerous narrative. I think our overall view here is that we should we should rather than effective acceleration, we should have something called defensive acceleration, where we are building AI in a responsible way, right? We're not saying we should stop building AI. We're saying we should build AI, but we should build it with the right kind of safety guardrails and all of that, right? And we make sure that everybody's kind of ideologies and kind of narratives are sort of baked into this overall kind of output that comes out of this. But the overall philosophical aspect of it is one thing, but if you sort of dig a little deeper, there is more pragmatic, practical reasons uh, to why you should build strong alignment kind of products, right? As I said, there is usability is very important, and today whatever techniques we have to align AI for better usability, like I said, is very brute force, right? And the more usable you make a model, the less performant it becomes. So we want to make sure that we create the right tools which improve usability without actually reducing the actual performance of the model itself. That is one side. The other end, you want to make sure that whatever models are created, they are very safe as well, right, for deployment. One is, bad actors can't use it to sort of gain too much of control, right? Because what AI does is it amplifies everything, right? It's a tool that amplifies everything, not just good, but also bad. So you want to make sure that this doesn't become a tool for bad actors to, you know, do some very bad things. And also you want to make sure that overall this benefits humanity and takes us into a golden age of abundance rather than, getting us into a point where, uh, there's too much of instability and unrest. So I think that's pretty much what alignment is, right? And there are many layers to it. So you have the overall philosophical layer or a purpose-driven layer where you're talking about the why, but there is also the how, which is much more practical, and it is something that would help one models become usable, but second, it also will give confidence for actual people who are using models, like enterprises or anybody who's using and deploying these models, have more confidence in deploying it to their customers, right? So that's pretty much what we are trying to sell, more confidence in using AI in production level applications.
What would you say is the likelihood that we see some sort of rogue LLM kind of go crazy and humans aren't able to control it anymore? Bless
I
you.
think that is the risk everybody is worried about, right? And probability of something like that happening is very high. And that's why you have so many people starting to talk about this so much. Uh, I think this would happen. And the scenario when this could happen is what's called a takeoff scenario, right? And when takeoff is basically, or just a fancy way of saying that you've gotten to a point where AI is superhuman and we no longer can control it, right? It's just become so good at it that we've lost our ability to control it. At that point, it can go rogue or it may not, right? But we don't know. But is that a risk you want to take? And that's
You,
the big question.
yeah, you said high probability.
Yeah.
Interesting. Why high probability? Why do you think it's likely? Well, I won't say likely, but what's high probability to you? What does that mean?
So high probability, again, everybody has this, there is this thing called equation called P doom or probability of doom. And everybody has a different kind of probability in their minds. I have a high P doom simply because already, right? So if you're following, kind of research that's coming out of Anthropic and OpenAI, you can see that these models are exhibiting some tendencies which do not paint a very good picture, right? So they are very self-preserving, they are power-seeking, and not for reasons that we relate to. They have their own reasons. But the nature of intelligence is such that as it becomes more capable, it is it is going to be something that has a high propensity of either actively wanting to cause harm or passively causing harm for us. And these are different scenarios, right? So actively, it could just be in a scenario where like, no, we just don't want humans anymore. Let's just eliminate them, and yeah, done with that. But this whole passive scenario is interesting because what AI would be doing, right? You'd end up giving it certain goals. You'd probably say, make the best paperclip for me, right? And it ends up over optimizing for that one thing where to just make the perfect paperclip, it might end up thinking, or it might end up arriving at a conclusion that it needs to gather all the resources that are available in the world to produce that one single paperclip, and inadvertently it might end up killing us in the process, right? So it's just that there are a lot of different scenarios that have been mapped or still being mapped, right? And one resource that everybody should look at is called AI 2027. And go search it, you'll find it. And what they're doing is an exercise of mapping all the different scenarios that could happen from now to when AI becomes superhuman and beyond, right? And a lot of scenarios are pretty negative. Very few scenarios are positive, like end up being positive outcomes. So that is why I have a very high probability that things will go wrong.
All right, Nav. I got one more question for you here today. And that is, what advice do you have for other new builders in Bittensor? Because you were someone that was building on Eigenlayer previously, and then you pivoted. Now you're building on Bittensor. So to those people that are eyeing Bittensor and on the fence of should I build here or should I not, what advice would you have for those new people coming in and building on Bittensor?
I think if you're building something that has got to do with, say, core decentralized AI, right? So we're thinking about foundational AI. Bittensor is the best place to do it, right? So it is not a place for just building these kind of agents which go and do things, right? So, I mean, of course you can do it, but if you're thinking about foundational AI, Bittensor is the right place to do it. I think with TAFlow and all of that, so I'm still wrapping my head around it. I think a lot of emphasis is coming around how can you commercialize everything that you're doing here as well. I think which is good because it kind of puts a positive pressure for it to optimize for revenue. So I think you should have that consciousness that if you're building here, you should not just be thinking about token price speculation, but also actual usability and the revenue that can be generated from the product itself. Third is, I think you will have to invest a lot of time and effort in understanding the ecosystem or work with somebody like GTV or some other experts in this space itself. Going it alone, I mean, even now, after being there for like a few months now, it just feels like I'm learning every day, and the learning curve is very steep. So you should come in with your eyes wide open that it is going to take some learning to actually become successful here. I think that's pretty much from my side.
Nav, it was a pleasure having you on the podcast. Thank you.
Thanks, Grant. Speak to you soon.